Thank you so much for joining this lesson. We shall be discussing Mathematics Paper 1, Section 2. And as we prepare for the KCSE 2025, we shall focus on the post-mock 2, Maranda High School. So remember to subscribe to our program and also remember to share the link with your friends. So allow me go directly to the Section 2 of this paper, the 80 marks. The optional marks here, whereby you choose your best 5 questions. So we'll be focusing on these questions, which are well thought out. This one requires your attention. This one requires a lot of concentration. So please make sure that you have your writing materials, you have your calculator, you have everything so that you may flow together in the discussion. As we continue learning, please allow me invite the continuing students in secondary schools and also in junior school for our program here, a very serious interactive program via Google Meet. So kindly invite your friends on our behalf to our program here. We shall be covering the term 1 work of 2026 via Google Meet, which is a very interactive forum. Learners can ask questions, students can answer questions, you can seek clarification from the teacher. You just interact like an ordinary classroom. So kindly reach out through our consultation line, which is on this poster, 0704 15 3366. That is the number you should use for consultations so that you may know much about our programs and so that you may also get some of the revision materials that we have for mathematics and physics predictions 2025. Number 17, which is the first question, ladies and gentlemen. Now, Wema Education Center ran 4 concurrent units for the pre-primary school, the primary school, the junior school, and the senior school. The length of the lessons for the units are 24 minutes, 30 minutes, 40 minutes, and 60 minutes respectively, and have different bells, and 4 different bells are used to signal the start and the end of a lesson for each unit. Part A determines the Roman 1 length of the shortest learning day in hours they have if the bells have to ring together at the start and at the end of the day. Therefore, for these concurrent units, we have the intervals of their lessons. Therefore, if the starting bell rings at the same time for all of them, then we can find the next time the bell shall ring again for all of them. And that is simply the application of LCM for the intervals so that you get the longest they take before ringing together. So 24, 30, 40, and 60, we find the LCM. The LCM of 24, 30, 40, and 60. Let us look at the LCM. We factorize the 6 of them. Factorize fully. When finding LCM, you factorize fully. It's not like when finding GCD, whereby you factorize partially until you get the common. Here, we need the greatest. We need the least common multiple. We need a multiple here, so we factorize everything. 24, 30, 40, and 60. Those are the intervals for pre-primary, primary, JS, and senior school. So we can factorize by starting with 2, which is the least prime factor. This gives us 12. This gives us 15. This gives us 20. And this gives us 30. Then the next we can go by 2 again to get 6, 15, 10, and 15. I think 2 can still go again. 3, 15, 5, 15. Then now we can proceed to 3, which is also a prime factor. This gives us 1, 5, 5, 5. Then by 5 we get 1, 1, 1, 1. Therefore, the LCM now, which is the interval they take to ring together all of them, shall be 2 power 3 multiplied by 3 multiplied by 5. Let's compute this. 8 times 15, giving us exactly 120. 120 minutes. And you know, we need the longest, okay, the shortest learning day in hours. The language there is hours. Therefore, 120 minutes should be divided by 60. This should be divided by 60. Then it shall give us 2 hours exactly. Shall give us 2 hours. Divided by 60. And you get 2 hours. So we shall talk about 2 hours as the greatest interval taken, the shortest learning day. Look at number 2. We also find the total number of lessons they have in a single day. So for the pre-primary, we take the duration of 120 and we divide it by the length of a lesson, which is 24. So when we take 120 divided by 24 minutes, we get 5 lessons for the primary school. For the pre-primary, then for the primary, their duration is taking 30. Therefore, this gives us 4 lessons. Then we take 120 and we divide by 40 minutes, we get 3 lessons. And now these are lessons, all of them. That's lessons. Then 120 out of 60, we get 2 lessons. That is for the senior school. So now we can talk about the total now. Total lessons. The total number of lessons. Total number of lessons shall be given as 5 plus 4 plus 3 plus 2. Now this gives us exactly, is this 14? Just confirm. Yeah, I told you people to be having your calculators standby so that whenever we compute a few things here, you're also behind what we are doing. Please make sure that you participate actively for that case. Please make sure that you are actively participating in our great lessons. Now, we focus on part B of this good question. Now, the question is asking this, the pre-primary unit uses a quarter of its lessons. A quarter of its lessons, the 5, for sleeping. This is a very good school, while the primary consume 12.5% of their lessons for physical education, that is PE. Calculate the time difference in time. Calculate the difference in time in hours the 2 units spent outside the class, given that both sleeping and physical education are done outside the class. So the pre-primary spend a quarter. So a quarter of 120 minutes minus 12.5% means over 100 of 120 minutes. Remember, the hour having 120 minutes. Therefore, when we take a quarter of 120, this gives us 30 minutes minus the other one, 12.5 over 100 times also 120. This gives us 15 minutes. So we get 15 minutes as the time difference. The pre-primary spends 30 minutes outside at the end of it. Then the primary consumes 15 minutes outside. So the difference in time spent outside is 15 minutes. But now we want the difference in hours. So 15 minutes, you can divide now the 15 by 60 so that you get a quarter an hour or a quarter hours or 0.25 hours. Yeah, so that is how the question is done. Throughout the paper, ladies and gentlemen, you are required to think. You are required to reason. You're required to reason throughout this paper. This is not a walk in the park. Guys should reason. Number 18. The figure below shows a cross-section of a model of an engine component of a cruise ship made of a semicircular piece of metal with a radius of 9 millimeters and center 0 attached to a trapezoidal end, in which AB equals to 16 millimeters, as you can see. Then BC, which is perpendicular, according to the angle there, equals to 6 millimeters, all right? That you can see. That we can see. That we can see. Then let's proceed now. Let's proceed to check a few questions here and there. Taking pi as 3.14 to calculate the part A, perimeter. Perimeter. Okay. To 1 dp of the cross section. Perimeter means you add all the boundaries of this. The arc length here, which is circular, the arc length there, which is a semicircle, then plus all the sides now, except the diameter, just the outer boundaries. Therefore, let's take the semicircle first, whereby we need half pi times d, and the d is 18 because we are told that we have a radius. We have a radius of 18. So we can compute this first. This gives me 28.278. Those are millimeters for the arc or for the semicircular part. Then we'll be adding, we shall be adding 16. We add 6, and we also add the length. We also add the length CD. Remember, the length CD is not known, and I want to extract it this way. There's something I want you to see, and please make sure that you see it as I draw this. Please make sure you see what I'm trying to teach you. Look at this. Let's look at this. There is the BC, which is having some height here of 6. So in case you connect perpendicularly, in case you connect this one horizontally this way, in case you connect like that, remember the diagram has not been drawn to scale. This diagram has not been drawn to scale, so the lengths are not actually what they are. It's just indication. If this is 6 centimeters, and from this point up to the top here, we have 18 millimeters. Yeah, we have 18 millimeters at that point. And we are very sure that this one is 6 because we are connecting horizontally 6. Then from this point to the top here shall be 12. So this is 12. So we shall use 12 and the 16 at this point for us to get the length of CD. So the length of CD now required that technical approach, whereby if you connect B to C, I think there was an issue with the diagram, should be indicating that if you connect from C to the horizontally, you will not go to the center of this particular semicircle. You will not go to the center because from A to the center is 9, but from B to C, it is only 6. Yeah, it is only 6. So that is it now. So we need now to use, we need to add everything now. 28.278. 28. Check, please. want to add all of them slowly. 28. The semicircular part, 28.728. 28.728 plus plus BA or AB 16, then plus BC 6, then plus, now we apply Pythagoras theorem. 16 squared plus 12 squared, the square root like that. So we are adding 28.728 plus 16 plus 6 plus, let's compute that part now. 16 squared plus 12 squared, we take square root. It's exactly 20. Yeah, that's exactly 20. Exactly 20. Square root of 400, It's exactly 20. So let's now add up everything. We talk about 28.728. We add 16 and we also add 6. Then we add 20, like that. 70.728 millimeters. But remember, we're supposed to do it to 1 dp. Instructions are very key. So 70.7 millimeters. That's simple, precise, direct to the point. Precise and direct to the point. Yeah, that's how we're supposed to do that part. I hope we were together in the analysis of the diagram. Remember our consultation line, which you can use to get the learning materials from us, is 070415 3366. There are those who are joining us late. Please ensure to subscribe to our platform and also to share so that you may invite your friends. This is the home of academics, shifting grades. Now at part B, we're determining volume in cubic, the cubic millimeters of the actual inching. Look at that. Remember the above is a model. Now we are talking about the actual inching, given that the thickness of the model is 3 millimeters and the length AB of the actual is 24 centimeters. Let's get to that. First, are we able to find volume of the model? Yes. Volume of the model, we've already been told that the thickness is 3 millimeters. So if thickness is 3, means now from here to that side like this, if we extend this, even here, if we are to extend, we would have extended by 3. Like that. It's 3 meters now. You know, that is the length now. 3 millimeters, meaning that we can multiply cross-section area times that length of 3 now. So let's get first volume of the model, whereby we need the cross-section area. Cross-section area, of course, being now semicircular and trapezium. And remember, the pi has already been given, 3.142. We start by the semicircle part. Half pi r squared. Pi r squared. Half pi r squared, that is the semicircle, plus half into length of 2 parallel sides. This is 18 and 6. AD and BC. 18 and 6 multiplied by the height between them, which is 16. So let's get the cross-section area first, or we just express it ago. This cross-section area now should multiply by length for us to get volume. Yeah, we can express at this stage, no problem. So half pi r squared, that is 127, sorry, 0.251. Then we add That's a 24, right? So 0.5 times 24 times 16, giving us 192. That is the trapezium side. Then now we multiply by 3. So the total cross-section area shall be, when we add 127.251, this is 319.251 times 3. Now we multiply the cross-section area by height, or rather lengths, and we get 957.753 millimeters cubed. That is now the volume, millimeters cubed. So we have volume of the model. We need now to get volume of the actual. For the actual, we're not given a lot. We're just given some corresponding length. So a length that corresponds to AB. You know, AB is 16. But now the AB of the actual is 24. Meaning that if this 24 is made same unit as what we are having here, millimeters, it shall be 240. Therefore, we can get linear scale factor. Linear scale factor. LSF. Linear scale factor. Yeah, linear scale factor. So remember that to find linear scale factor, you just need to divide, or you get the length of the model out of the length of the actual, or the other way around. Any can be the numerator in such a case, as long as you relate corresponding lengths. So you get linear scale factor this way, by saying that linear scale factor equals to, I'm trying to write it clearly. Linear scale factor equals to, we take 240, the AB of the actual, out of 16, which is the AB of the model. 240 out of 16, this is 15. That is the linear scale factor. Meaning that volume scale factor now shall be, when we take linear scale factor and we raise it to power 3, we cube. Volume scale factor equals to linear scale factor raised to power 3. So when you cube these, you're getting 3375. That is now the volume scale factor. So when you divide volume of the actual out of volume of the model, you are now supposed to get 3375, meaning that to remain with X now, you multiply 3375 by 957.753. This gives me exactly 3232 416.375. This is cubic millimeters, just as the examiner demanded it. So that's how you're supposed to work out such a thing. It's a very detailed question. Don't joke with it. That's a very detailed question. It requires a student to have an information of what they are doing. Remember, we've started by a cross-section area. Then we add to know that the instruction here of 3, the thickness here, is now supposed to be used to help us compute volume of the model. Then with volume of model, now we proceed to use volume scale factor. And we are beginning from linear scale factor because we are given corresponding lengths for the model and for the actual engine part. You see? So you're supposed to be very conversant with mathematics, ladies and gentlemen. Okay. We need now to check the last part of this question. The last question of number 18, the last part of number 18. The question says that we find mass, and mass is to be found to the nearest decagram. Nearest decagram. Very special and unique instructions. Let me check first whether there was anything to do with the accuracy for the volume. No, we don't have accuracies. We don't have accuracies like nearest to number. We don't have such a thing in that particular question. We don't have. So now let's proceed. Let's proceed into the calculation now of part C. To the nearest decagram of the component, given that it is made from a metal whose density is 1850 kilograms per meter cubed. So we can change the density first and say that the density equals to 1.85 grams per cubic centimeter. We divide it by 1,000. We just make it conversant with the values provided. Then the volume in this case, the volume can also be converted. Remember, it's in cubic millimeters. So let's say that 1 millimeter is usually equal to 10 centimeters, meaning that, no, 1 millimeter, 10 centimeter, meaning that when the millimeter is cubed, it is millimeters that make a centimeter. Sorry, I think we should be very careful at that point. Please look at this conversion. It's a very interesting conversion. Very interesting conversion. But you just don't have to divide and multiply values without exactly knowing what you'll have done. Without exactly knowing what you've done. Be patient with the network. Yeah, let's be patient with the network. And it's my hope that you guys remember our serious program here. Please invite your brothers and sisters who are in junior school, who are reporting for Form 3 and Form 4 next year. Please invite them to our program. The consultation line is here, 070415 3366. Let's check now. Yeah, let's check the question. Now, we are told that 1 centimeter is usually given by 10 millimeters, meaning that when you get to volume by cubing this, you also cube the equivalent millimeters. So when you cube 10, you get 1,000. If 1 centimeter equals to 10 millimeters, then 1 centimeter cubed means you also cube the equivalent millimeters by multiplying it 3 times. So it becomes 1,000. So 1 centimeter cubed equals to 1,000 millimeters cubed. What about when the millimeter cubed are 32, 416, 0.375? This has to be divided by 1,000. And the volume becomes what? Volume becomes 32 point. 416,375. That's a terminating decimal. These are grams now. These are volume in cubic centimeters, sorry. So how shall we get mass? Mass is given by volume times density. The general formula that density equals to mass over volume. So how will you remain with mass? You multiply both sides by volume. So volume times density, 1.85 times 32, 32.416,375, and this becomes 1.85. So this shall give us 59.79. 59.97. Yeah, 970 294. And these are grams. Yeah, these are grams. Now the next thing now is what we call conversion now. So you ask yourself, if 1 gram equals to 10 decagrams, 1 decagram equals to 10 grams. 1 decagram equals to 10 grams. I want to express that conversion just now. Say 1 decagram equals to 10 grams. What about when the grams are 59, 79.9700, you know? Yeah, it's such. So you should be able to talk about this value now divided by 10. So we get 597.997. Then now that we are talking about the nearest decagram, then we're supposed now to convert. And this becomes 598 decagrams. So that is the conversion you are supposed to do in such a case. Number 19 now. 3 towns, A, B, and C, are such that B is 530 kilometers on a bearing of 295 degrees from A, and C is 750 kilometers east of town B. Using a scale of 1:10 million, draw a scale diagram showing the relative positions of the 3 towns. The language of east should be understood very well. The language of east, west, north, and south should be properly understood. In a previous video that has already been uploaded in this precious channel, we've already emphasized that when we are told to the east, you usually move to your right hand side. And this should be horizontally. When the examiner talks about west, please move to your left hand side and still horizontally. Don't try to move anyhowly. Make sure you move horizontally. When we talk about north, you're supposed to move upwards. North, you're supposed to move upwards. Upwards and not to any direction, but vertically. Then when you talk about south, ladies and gentlemen, you are supposed to move downwards, horizontally downwards, vertically downwards. Downwards. Move downwards. Confirm whether you can see things clearly. See, sometimes the screen is misbehaving, but the point is home. The point is home. So the 3 towns now, let's look at how they are related. Let's check how they are related. We've talked about a town A, B, and C, such that B is 530 on a bearing of 295. The other thing we're supposed to interpret very carefully is the scale. These are centimeters. 1 centimeter. You know, when it is given in scale, it means the same units. So 1 centimeter on the ground. 1 centimeter on the ground. I'm setting the sensitivity of this pen, so just relax. 1 centimeter represents 10 million centimeters on paper. So 1 centimeter represent, we convert these centimeters now to kilometers by dividing by 100,000. When you divide by 100,000, you get 100 kilometers. So 1 centimeter shall represent kilometers, 1,000 of them. Is that okay? Yeah, kilometers have 100 of them, that is 100 kilometers. Yeah, 100 kilometers. So now if it represents 100 kilometers, instead of 530, we shall have 5.3. Instead of 750, we shall have 7.5 centimeters. Let's start now interpreting these. 295 from A, that's true bearing. So we start with A. We start with point A. Then how do we locate B? With this point A, then we're supposed to measure 295. Remember, your protractor can only measure 180 is the maximum. So if we need 295 after the automatic 180, what more are you adding? 115. So you just stand here, place your compass there, and you add 115. Remember, true bearing should be measured strictly from the north and in the clockwise direction. And in the clockwise direction. So you measure 115 like that, and you produce it. Yeah, I've added 115 at this point, meaning that now 115 plus the 180 gives us 295. Then after that, now we measure 5.3 centimeters, which now represent the 540. Then after the mark, you raise a very good compass at that point. A very good compass at that point. Now this is where B is. According to our instruction, this is where B is located. That's where B is located. Then once we've located B, let's continue to locate more. Then C is 700 to the east, 750 to the east of B. So when it's B, you move horizontally, but towards the right-hand side. Towards the right-hand side. Like that, towards the right-hand side. You just move horizontally. Then you have to put a mark after measuring 7.5. 7.5. 7.5 centimeters. You get C. That is the position of C. And raise the compass still. At that point, you can give us a compass like that. So we are having now the relative positions of the three towns. But yeah, three what? Yeah, the 3 towns now. The 3 towns have been represented. Let's check what next after that. Locate another town D, which is on a bearing of north 40 degrees towards west of C. And 600 kilometers from B. 600 kilometers from B. Therefore, while standing at C, at the north towards the west, 40 degrees. So you get to C from north, 40 degrees towards east. You produce a line 40 degrees towards east. We've already interpreted this, so allow me clear it so that now we may place our 40 and we produce a line. Just produce a line like that. You've measured what? 40 here. That is the meaning of compass bearing. From north, 40 towards west. From north, 40 towards west. Then from B, the same town D, 600 from B. So that needs 6 centimeters now according to our scale. So stand at B and you use 6 centimeters to make an arc. So standing at B, you make an arc. That becomes our D. You now have to join it to, B. Yeah, join it to B like that. You see? Like that. We have shown the location. See? And after that, you are told hence. If you're told hence, measure the distance between A and D, giving your answer in standard form. Between A and D, you just use your divider or your sharp compass. Okay, a compass with a sharp pencil or a divider. It's most convenient. You stand at A, you open the divider to D, then you transfer that measurement to the ruler. You transfer the measurement to the ruler, then you discover that the distance from A to D is 7.2 centimeters. 7.2 centimeters. 7.2 centimeters. 7.2 centimeters. Then now you will say you need 7.2 divided by 100 to get your actual distance now in kilometers. So 7.2 times 10 power negative 2. That's after you've divided by 100. And you will have gotten your distance in kilometers, and it is also in standard form. Calculate in part C now. In part C, they are talking about calculating, not measuring. Let's look at that keenly. Calculate phi. Length to the nearest meter of the straight road linking A to C. Straight road linking A to C. The road linking A to C. Let's check some of the angles here. Can work with some angles first. Let's work with angles. You know, there are a few things that we're supposed to do. One, you're supposed to understand that if this was a, let me show you some angles here. There are some angles I want you to understand. There are some angles here I want us to interpret together. We said you measured 115, meaning that from 115, if you subtract the 90 at that point, then you shall discover we have an angle of 25 here. An angle of 25 here. Or rather, with the 295 from 360, you should discover that we add 65 here, meaning that there is a 65 automatically at this point. And if that is 65 then, and we are moving horizontally to C, then we will have automatically 25 there. So we have an angle of 25 at that point. An angle of 25, and we are having 530 here, kilometers, 760, 750 here, kilometers, and the side here. Side can be called small letter b, it's not known. That is what we want. So because we've been instructed to calculate it, then we're supposed to use the cosine rule, not measuring. You just compute it, calculate it. So according to this cosine rule, b squared should give us b squared should give us c squared, which is 530 plus a squared, which is 750 minus 2 multiplied by 530, 750, the cosine of 25. Yeah, the cosine of 25. So let me take 2 times 530 multiplied by 750, the cosine of 25. Then now we talk about 530 squared plus 750 squared minus the answer that we are having here. Now we get b squared as b squared equals to 122, 885. 122, 885.3093. I don't know whether you can see that. But anyway, the square root of this shall give us 350.55 to the nearest meter, 351. 351. But to the nearest meter, sorry. These are kilometers. Is that true? These are kilometers. So these kilometers, we can multiply by 1,000 to get meters. So in meters, I'm having B as 350,550.0097, meaning that it's just 350,550 meters. 350,550 meters. After the computation in kilometers, then I multiply by 1,000 to get meters. Then you round off the meters now. Yeah, you round off the meters like that. Look at part 2 of that. Part 2 of the same question. We need the distance to the nearest meter of a surveillance mast, which is equidistant, read that, which is equidistant from the 3 towns A, B, and C. A, B, and C. A, B, and C, such that in case a circle is drawn, it will touch A, B, and C. That means we need the center of such a circle. The center of such a circle, meaning that we talk about now circumscribing, but now we ask ourselves, when a circle has been circumscribed, instead of constructing, are we able to get the radius using the sine rule? Sine rule says, sine rule equals to twice the radius. If sine rule equals to twice the radius, then we say twice the radius equals to sine rule, whereby we can take the length B that we've already computed, 350, 550 in meters, out of the sine of 25, which is the opposite angle to that. Then R shall be, we divide everything by 2. Yeah, we divide everything by 2. So this value divided by 2, the sine of 25. And it shall give us 414,735.994. 994, yeah. But now to the nearest R, to the nearest what? Meter should be 414,736. 414,736. 414,736. 414,736. Yeah, 414,736, like that. So that's how the third question was supposed to be done in this interesting paper. Look at number 20. The determinant of a matrix AB, you know, AB is the product of A and B, is 10. Determine the value of K, then also determine the inverse of AB. Let's check at the multiplication first. 2. Check multiplication first. We check multiplication first. So we are having 2, 4, 3, and K multiplied by 4, 1, 5, and 2. What is it giving us? Row times column. So 2 by 4 and 4 by 5. 8 plus 20, that's 28. Next should be the same row, the next column. So we talk about 2 by 1 and 8 by 2. That's 2 plus 8, 10. I hope it's properly computed anyway. On the other row of answer now, we need this row times the same columns in that order. 3 by 4 and K by 5. That becomes 12 plus 5K. Then we can talk about the same row by the last column now. 3 by 2 and K by 4. That is 3 by 1 and K by 2. So 3 plus 2K. Yeah, like that. Can we talk about now the determinant? What's determinant? Product of the elements in the leading diagonal. You shall allow me use the space above this question, please. Yeah, the space above the question. Product of the elements along the main diagonal, this one, minus product of elements in the other diagonal. So 28 into 3 plus 2K minus 10 into 12 plus 5K. 12 plus 5K. Now this should give us exactly 10 according to the instruction. That should give us 10. If it gives us 10, then we can talk now about the value of K. 28 by 3. That gives us 84. That gives us 84. Then plus 56K. Mm-hmm. 84. Okay. 84 plus 56K minus, is it 120? And minus again 50K equals to 10. Grouping of terms here, we shall have 84 minus 120, 36, and 36 becomes positive on the right, but it has to become now 46. this is equal to, we are having 56 minus 50. 56 minus 50 should give us 6. To 6 minus 50. 6. We get 6K. 6K equals to 46. 6K equals to 46, giving us the value of K as 46 over 6. 7 2/3. Let me confirm whether, or we can confirm together whether we are arranging our terms together. Let's just confirm. It's a confirmation. It's a confirmation. The multiplication we did very well, but when now it came to determinant, when it came to determinant, yeah, I think that is well calculated, unless there was an issue with the typing here. I expected a whole number. Unless there was an issue in the location of the determinant there, and we can proceed now to determine the inverse of the matrix AB. How would we get inverse of a matrix? How would we get the inverse of a matrix, which is here? The inverse, let me get the specific matrix first. 28, 10, then the other elements are, these answer here should be multiplied by 5, then we add 12, 50 1/3. 50 1/3. The next should be 7 2/3. The 2/3 should be multiplied by 2. 7 2/3 by 2, then plus 3. You get 18 1/3. Yeah, 18 1/3. That is now the actual matrix. Remember, the determinant is 10 for this particular matrix. If the determinant is 10, then we need to divide everything by 10. So for us to get inverse, we need 1/10. 1/10, then 1/10 now multiplies. 1/10. 1/10 multiplies when you change the positions of the elements. If it's 28 and 18 1/3, they change positions. So we shall have 18 1/3 taking this position, then 28 now switches the position with 18 1/3. From there now, you should be able to know that on the other diagonal, we change the sign. We change the sign here. Therefore, 18 is having a third there. Then 28 comes here. Then here we just change the sign. -50 1/3, like that. So this is now the inverse that we needed. Remember, it's already correct, but you can proceed to open the brackets by dividing everything. Literally, you can divide everything now by 10, but already this expression will earn you the mark for your answer. I think there are some word problems here on matrices and we need to check them. Miss Pamela wanted to buy 90 loaves of bread and some packets of milk for a total of 59.40 Kenya shillings. However, she could not get all of them in one shop. At shop A, she got 54 loaves of bread and 20 packets of milk and paid 37.60 for them. All right. She picked the remaining loaves of bread and 10 packets of milk from shop B. Given that given that the prices of the two commodities were the same in the two shops, form two simultaneous equations from the given information. Hence, use the inverse of matrix B in A above to determine the price of each packet of milk and loaf of bread. Therefore, we shall say that 54, we can let the price of a loaf of bread be X, then a packet of milk Y. So that 54 times X, when we add 20 times Y, she spent 37.60. Then the next thing that she did is to proceed to shop B, whereby she picked the remaining loaves of bread. You know, she was to buy 90, but now from A, she has gotten 54. Therefore, she is yet to purchase 36 at the same price and 10 packets of milk. And this should total to, she was to spend 59.40, and she has already spent in shop A 37.60, meaning now she's going to spend 21.80. Please check that. She has spent this in shop A and her total budget was 59.40, like that. So we are having now equation 1 and equation 2. Just because of what we've discovered here, allow me not to. Actually, there was an error in the typing of these. Therefore, allow me to just solve using the matrix method independently. The matrix method independently. So what we are supposed to do for us to solve it independently is to ensure that, okay, you can simplify the equation, which is not a must. You can simplify, which is not a must. So you can just extract a matrix equation now. 54. 54. Start with 54, then 20. Then after that, we have 36, 10. I think there's something wrong with the sensitivity of the screen. Something is wrong with the sensitivity of the screen. And I'm fixing it. Yeah. Checking my stylus pen so that I don't have the challenge prolonged. So we're talking about 54, 20, 36, 10. That is the coefficients matrix, then variables matrix, then constants matrix. Yeah, sounds matrix like that. So we have the matrix equation. The next thing that we're supposed to do, boys and girls, please ensure that you find now the determinant and hence the inverse. Determinant and hence the inverse of the coefficients matrix. So we need 54 by 10, that is 540, minus 20 by 36, that is 720. We get negative what? 540 minus 720, we get negative 180. So now we want to divide everything by 180. So negative 1 for 180 into, I want to show you now what the inverse is. 10 comes here and 54 comes here. Then this becomes -20, this becomes -36. This is the inverse. This is the inverse of the matrix. Maybe that's what we needed. So now this should multiply. This should pre-multiply now. This is now the inverse. It should pre-multiply both sides of this matrix equation. Both sides of the matrix equation. So if it's both sides pre-multiplied, means it's the one to start here. -1/180, 10, -20, -36, 54. Then now we have 54. Yeah, 10 and 20 at this point. XY equals to, you also pre-multiply the other side. You also pre-multiply the other side. And in that case, now you say it's equal to we multiply by, you start with -1 of 180 into 10, -20, -36, 54 into the constants matrix. So the constants matrix is 3760 and 2180, like that. So now with this, we need to know that on the left-hand side, a matrix times its own inverse should give us the identity matrix, which is 1, 0, 0, 1 times the variables matrix equals to, now on the right, we are supposed to multiply now. This one, we are supposed to multiply. Let's start by 10 into 3760 minus 20 into 2180. That gives us -6000. So we'll have -1/180 to -6000. Then we have -36 into 3760 plus 54 into 2180. This now gives me -17,640. Meaning that if we continue now multiplying everything, first, matrix times the identity matrix remains the way it is. But here we have to divide everything by 180. This becomes 98 and 6000 by 180. Yes, 6000. I hope that was right. 6000 by 180 becomes 33 and a third. 33 and a third. So X, which is a loaf in your shillings, then a packet of milk, which is Y, was 98. Those are the values that you're supposed to come up with. Those ones are the values that you are supposed to come up with. A very good question. A very good question, though very involving. It has a lot of steps. Yeah, so I hope I hope everything has been computed properly. Yeah, that way. That way. A very good question. Let's check number 21 now, which is on area approximation. Huh. The diagram below shows a sketch of two curves drawn on the same grid, but not to scale. So they have been sketched, in other words. Determine the coordinates of point A and B, the intersection of the two curves. Okay, you can see first at A, the curves are intersecting on the vertical axis. So something we must be very sure about coordinate A is that at A, the coordinates of X is 0. So if the coordinate of X is 0, then we can use any of the equations to find Y. Y equals to, according to the first equation, 0 squared minus 2 into 0 plus 4. So Y is 4. So the coordinate of A, 0, 4. Very simple, because at A, the coordinate of X must be 0. That way. Then what about the coordinate of point B? Then we're supposed to know that, because at B, the curves are intersecting, then we can equate or solve simultaneously anyway. So we can equate x squared minus 2x plus 4 equals to negative x squared plus 2x plus 4. A few terms here shall be cancelling out. 2x squared minus 4x equals to 0. Equals to 0? Yeah. Equals to 0. Then this has to be solved. We can have 2x factored out to remain with x minus 2 equals to 0. So x equals to 0. You know, we're getting two values of x. X equals to 0. And x equals to positive 2. Yeah, x equals to 0 and x equals to positive 2. Because 2x equals to 0 gives us x is 0. And x minus 2 also equal to 0 gives us x equals to positive 2. If x is positive 2, then, ladies and gentlemen, if x equals to positive 2, then it has to imply something. It has to imply that the coordinate at that point of x is 2. And when x is 2, we can find y. When x is 2, we can find y using any of the equations. We use the first equation. When x is 2, y shall be y equals to, using the first equation, 2 squared minus 2 into 2 plus 4. This is 4 minus 4 plus 4. We get y is 4. So the coordinate of B is 2, 4. The coordinate of A is the one that takes up the 0 here. And we've already applied that and got A as, we've already gotten A as 0, 4, like that. So we have the two coordinates. You just solve the equations simultaneously, as long as we are talking about intersection of the two curves. Yeah, as long as it is intersection of the two curves, then you talk about simultaneous solution of the two equations for the curves. Even two straight lines, that's how they are solved. You should be able to understand a few things here and there. Thank you for following. Thank you for following. Remember to subscribe, remember to share, remind a friend, invite somebody to our serious lessons. We are climaxing the preparations of 2025 national exams. We've been here for KGCR, and now we are inviting all the KCSE candidates to be on board as we continue covering some good work. Yeah. Okay. Can we check the next question, ladies and gentlemen? Now, using the trapezium rule with 4 strips, estimate the area bounded by the curve between points A and B. All right, one thing that you're supposed to know here is that, okay, we're going to estimate using the 2 methods. But one thing you're supposed to know here, we are moving from x equals to 0 to x equals to 4, and we are supposed to use how many strips? 4 strips. So from 0, x equals to 2, from 0 to 2, and we need 4 strips. Then it means we shall use intervals of half, so that the strips are, we must use 0.5, and we must use 1.5. For us to get 4 strips, we use intervals of 0.5. Therefore, we get points of x first. Points of x. I don't know whether I do 2 methods, then we compare, or I just approach it once. So I will teach you something about when curves are intersecting like this using the trapezium rule. Then I will let you, during your own time, you apply the same for mid-ordinate. So for mid-ordinate, we shall just do once. But for the trapezium rule, we will do the 2 methods. So y's are 2 for the 2 different curves. Y's are 2 for the 2 different curves. Where we are having 4 strips. Remember, we are having 4 strips. So now I shall start from 0. I go to 1.5. I go to 1. I go to 1.5. And I go to 2. Exactly 2. So let's check values of y. For the first curve, I call it curve 1. For y1, now for the first curve, which is here. Actually, we don't know which curve is labeled what. Actually don't know which curve is labeled what. But we just get values of y. And also we get values of y for the other curve. So we talk about y2 using the other curve. So we shall have y1 and y2 for the 2 different curves. For the 2 different curves, we shall have y1 and y2. So y1 and y2. Y2. I don't know why it's not writing very well, but let's check. So we can use any as the first equation. Any should be the first equation, then automatically the other becomes the second equation. I'm checking something on my stylus pen, which is really interrupting. Okay, let's check now. By 2, okay, it's now good. So allow me use the first equation here, this one. So when we start with 0, we just get 4 here. Then when we go to 1.5, we shall have 1.5 squared minus 2 into 1.5, then plus 4. You know, this is giving us 3.25. Then at 1 shall be 1 minus 2 plus 4, giving us 3. When we go to 1.5, sorry for that. I think before 1, we should be having 0.5 and not 1.5. Sorry for that, guys. 0.5 should be squared minus 2 into 0.5, then plus 4 now. We're getting the same value anyway. Let's go to 1.5. 1.5 squared minus 2 into 1.5, then plus 4, 3.25. What about at 2? To be 2 squared minus 2 into 2, then now plus 4. This gives us exactly y equals to 0. This gives us y equals to 4, sorry, not 0. Y equals to 4 because of x squared is 4 minus 2 into 2, then plus 4, we get 4 here. So those are the values of y. What about for the other curve? What about for the other curve? What about for the other curve? For the other curve, now let's talk about, see, we start with a negative. So at 0, we insert zeros here, and this still becomes a 4. Then when we insert 0.5, it shall be negative 0.5 squared plus 2 into 0.5, then plus 4. That gives us 4.75. Then with 1, it will be negative 1 squared. Plus 2 into 1, then plus 4. We get 5. Then at 1.5, we talk about negative. 1.5 is squared plus 2 into 1.5 plus 4. This gives us 4.75 again. And finally, with positive 2, what do we get? Negative 2 is squared plus 2 into 2 plus 4. This gives us exactly 4. Wow, so that's how the curves are simply behaving. The first approach, after you've gotten the values of y, the first approach, just remember that area is given by half height into the first y and the last value of y plus 2 into the y's that are in between now. You add all the y's that are in between like that. So we have to start with half y, like that, half h, which is half the interval that we are using. Half the interval applied, like that. You're supposed to be knowing a few formulas. Don't just get a 0 when some of the questions are just a matter of memorizing a formula and you apply it. You see, you substitute. So here, we can find first, according to the first approach. So that is the universal formula, regardless of my two approaches to this question. You can get area between the first curve and the x-axis. Also, area between the other curve and the x-axis. Area below this curve and x-axis. Area below the other curve and x-axis. Then you subtract the two areas. You get area bounded by the two curves. So using the first curve, it's half. The interval used here is 0.5. So that's our h. Now the first y is a 4. The last y is also a 4. Then plus 2 multiplied by the y's between there. 3.25 plus 3.25. Like that. So let me compute the answer without wasting time. Without wasting time, you shall allow me use the formula. 3.25 plus 3 plus 3.25. Then we multiply that by 2. Then we add 8. That is after adding the two fours. Then with this now we can multiply it by 0.25 after dividing 0.5 by 2. This gives us 6.75. 6.75. 6.75. That is one of the areas. That is one of the areas. That is one of the areas. What about the other area? What about the other area? Now you use the other curve. You use the other curve and you'll be substituting what? Let's say that was area 1. Then we talk about area 2 at this point. Half the same interval into first y4, last y4, plus 2 multiplied by the y's in between. Allow me compute up to the final answer. 4.75 plus 4.75 and plus 5. Then we multiply these ones by 2. We get 29 plus 8. Then we multiply by 0.25. This gives us 9.25. 9.25. So with this now, we're supposed to talk about area. Now the area between the two should be 9.25 minus 6.75. So when I subtract 6.75 from this, I'm getting 2.5 units. And the units are squared. In other words, they are units of area. 2.5 units. That is now how you are supposed to find the area bounded by the two curves. Bounded by the two curves between points A and B. You find area below one curve and x-axis, area below the other curve and x-axis, and you subtract the two. You shall find the area between the two curves. Alternatively, you can now find the y after subtracting all the y's now. So the y between the two curves. At this point, you get the difference so that you may get the y here. The first y minus the second one. The first y minus the second one. So in the first case, you find this is a 0. And also here, 4, this is a 0. So we need now to take absolute differences actually. So 4.75 minus 3.25. Now that gives us 1.5. So 1.5. This difference should be 2. This difference should be 1.5. So now we can say that the area directly, this is alternatively now, we would have gone for area equals to half into So we can talk about F times the interval between the values of X, which is 0.5, looking for some good looking for sensitivity in this particular